91, 93, minimum number of moves to make palindrome. So we are giving a string as only consisting of lowercase English letters. So in one move, you can select any two adjacent characters of S and swap them. So we're going to return the minimum number of moves needed to make S a palindrome. So note that the input will be generated such that S can always be converted to a palindrome. So let's just try an example. So if we have a string like let me just use the first example. So if we have like AA and BB, and we're going to do the swap operations. So for example, we can do the operations with this AB. So it's going to become a BA. So here is A and here is B. And then we're going to swap those two characters. So this is AB and this is going to be BA. So how many swaps? 1, 2. So there are going to be 2 swaps. So we're going to return 2. So another case is that instead of the result is ABBA, so what about it is BAAB? Is that possible? Yeah, we can continue to do that. So let me just remove those cases. So instead of swap A and B, so what about we swap? Yeah, we're gonna swap two neighbors. So we're gonna first of all we're gonna swap this AB. So it's gonna become AB. And instead of swap this AB, and we're gonna swap this AB, so it's gonna become BA. So this is a BA. So this is another case, I think. So before, before we have the ABBA. Now we have BAAB. If my calculation is right, yeah. So. But it seems it is easy to do the operations by ourselves, but for programming, it's going to be really hard. Actually, the intuitive idea is that, so for example, we have like AA, BB. What about we have another character C? So C is the only unique character. So this means this character C should be in the middle. Yeah. So if we find such cases, if there is a single character at the right side, yeah, so we want to put it in the middle. So now it becomes A, C, B, and B. So now what are we gonna do? If we put C, put this character, if we want to put this character C in the middle, now we still need to do the swap. Yeah. So for example, this A and B should be so this A should be swapped here, and this B will be but we still need to do the operations. But at the moment, let's just ignore this character C. What happens for this AA and BB? Yeah, because if we have a single character C, definitely we need to put it in the middle. If we put it in the middle, definitely how many steps, it depended on the index. So for example, if the index is L, so here I use L, it's going to be L divided by 2. That's going to be how many swaps? It's going to be 2 swaps. So this means if it's use 2 swaps, so this character C is going to be in the middle. Yeah. So this is the base case. So if we put C in the middle, what about this A and B? Because at the left side there are 2A and the right side there are 2B. Do we need to swap with this C again? You know, if we do a swap, C gonna be here and A gonna be here, and then we're gonna do a swap, B gonna be here, A gonna be here. We don't need to do that. Yeah, we just need to check how many swaps for this character C. If we put it in the middle, actually we will not put it inside. We just ignore it. Yeah. So if we find this character C, we just ignore it. So it's going to become AA and BB. Now, we still check from the left and from the right side. So from the left side, this is the character A. And we're going to check from the right side. So first of all, we're going to turn this string into array. So we're going to check this character B. Now, we want to check from the left to the right. We're going to be the first character B. It is this one. Yeah. If we find this one, how many swaps? If we want to get this b. So this is just the greedy idea. So from the right side we have a b, and now we want to find another b. So we need to calculate how many swaps. Actually, we will ignore that character c. Yeah, because otherwise there will be more swaps. So how many swaps? B gonna swap with a, and this b gonna swap with another a. So it's gonna become something like b a b. So how many swaps? There are gonna be 2 swaps. Yeah. So after 2 swaps, we're gonna ignore this b, and we're gonna ignore this b. So what's left behind is AA. Definitely AA is okay. We don't need to have any kind of swaps. Yeah, because so for example, for this character A, it is here, and then we find another character A, and we want to put this A to the left side, but this is what only left, because this A has already been at the left side. This means we will not do anything about it. Yeah, so this is the basic idea. Maybe the difficult part to understand is that what if we have a single character C, and why we will delete it immediately? Why not we just put it inside, and then we're gonna do the swap operation. So for example, this is B, we find B here. Maybe this gonna increase the swaps. Yeah, but actually we don't need to do that. So this means inside the calculation. So inside the calculation, we will ignore this character C. Yeah, now let's just start coding. Let me just start coding. I think this is the most difficult part to understand, but let's just start the coding first. First of all, let's just turn this string into a list, and then we're gonna directly check the unlist. So while there's something inside of the list, we're gonna find the left pointer. So from the left side, we're gonna use a left pointer, and we're gonna use s dot index. So we're gonna check it from the left side. So we're gonna check the right character. It's gonna be s -1. Now we want to check the index of L. If it is equal to the last one at the right side, length of the string and length of the array -1. So this means this is the only single character we need to find. So what are we gonna do? We're gonna update the counter. So here we're gonna use the result. So this result, we're gonna set it to, yeah, I forget how to recover it. So this is so difficult. Yeah, let me try to let it go back. I don't know. Yeah, now we've covered it. So result gonna plus equal to L divided by 2. So if that is the only single character, so definitely we want to put it in the middle. But actually we don't need to do the operation. We don't need to put it in the middle. We just need to count it. So this is the result. So otherwise, if we can find it from the left side, so this means result gonna plus equal to the index L, and we need to pop it. Yeah, so s dot pop at the index L, and finally whether it is the single character or we already found it from the left side. So definitely we're gonna put it from the right side. So s dot pop from the right side. So finally we just need to return the result. So this means how many count. So let me just run it. As you can see, it works, and let me just submit it. Yeah, as you can see, it works, and it's pretty fast. And the time complexity is O(n) squared, because this is a while loop. There are n characters inside of the string s, so this is O(n). But for here, we're going to use the index to find the first character from the left to the right. So this is another O(n) type. So the final complexity is going to be O(n) squared. I think the most difficult part is about this one. So if something is like AA and BB, we still use the greedy idea. So this is a B, and we're going to find this B, and we're going to count it. So after the swap, even though we didn't do the swap, but we do the count. So after the swap, actually it is AA. We did the count, and we pop this B, and we pop this B. What's left behind is AA. And this is from the right side, and this is the L product from the left side. If this is L, and we still need to count it. But currently the index L is 0, so we're going to count it as a 0, and we're going to pop it out, pop this out, so this is empty. So this is okay. Yeah, but the difficult part is something different. So for example, we're going to have something like AA, BB, and C. So if we find this character, this is a single character, actually we need to put it in the middle. Yeah, but we just need to count it. Actually, we don't need to put it in the middle, because if we put it in the middle, it's gonna have more swaps. Yeah, so currently our idea is that we just count it. If we find this one, we just count it, because we still have the greedy way to solve the problem. So for example, we just ignore this C. We just put it there. We just ignore this character C, and we do the calculations from here. So for this AABB, we know that we need 2 swaps of operation. So this B gonna be at the right side. So it's gonna be B, A, and B. It's gonna be something like that. And for this character C, we will ignore it. We just put it there. Yeah, because for the greedy idea, we can do it at here, but this is not the greedy idea. We put it in the middle, but we will just ignore it. We just put it there. That is okay. Yeah, we just ignore this single character C, and we will calculate it later. We know that definitely we can put it in the middle. So we will deal with this one. Yeah, so for this B, it is okay, we will ignore it. And for this AA, it is okay, we will ignore it. So what's left behind is this character C. Yeah, but for this character C, we need to put it in the middle, but currently there's nothing. But we already know how many characters in total. 1, 2, 0, 1, 2, 3, 4. So the index is 4, so 4 divided by 2. It still means we need to have 2 swaps, and then we can put C in the middle. So this is why, even though we calculated from here, actually we didn't put it in the middle. We calculated for the final operation. We've already finished all those areas, then we put it in the middle. So this is the very difficult part to understand the problem. But if you understand this way, we're gonna use the greedy one to solve the problem, and we're gonna solve it, but actually we didn't delete it, we didn't move it, we didn't swap it to the middle. Actually we just count it, because finally the minimum swap gonna be L divided by 2. Yeah, and we know that because currently we didn't do anything, but finally after finishing this one, we can do it, we can put it in the middle. So this is the idea. I think that's all about it. Thanks for watching, see you next time.